Folks, hi folks. Welcome to your first, I guess, virtual math class from Mr. Morash. We're going to start with just a little bit of a recap because you haven't had a lesson in a while and you're sort of been working on your own, which is fine, but it's nice to make sure we're all on the same track. So some of this is where we're going, some of this is what we've done, some of it is the work you're working on right now, and I'm going to do a lesson first just with that recap, then I'm going to do some determining intercepts of linear functions, then we're going to do some looking at some intercepts and interpreting slope, and once we're through those, you'll sort of have what you need for that next assignment I posted. I'll post two more lessons as well, one on slope of a line segment, slope formula, a little bit later. So let's take a look at this. All right, so this is the materials for 050520. And just pointing out classifying these as linear or not linear. This first example is linear. That is because its variable x has a power of 1. It would make a straight line. If I used a graph or I used table values, it would turn out to be a solid straight line. If I take a look, and this one didn't turn out beautifully, but with the x and y axis there, we have a non-constant increase in the y or the independent variable for each equal increase in the dependent variable. So this is not linear. If you take a look closely at these ordered pairs of 0, 5, 2, 9, 1, 7, negative 1, 3, I'm actually going to put those into a table of values. I'm going to go reordered. So we have negative 1, 3, 0, 5, 1, 7, 2, 9. Then I'm going to take a look at the changes in the x and the changes in the y. The changes in each x value is an increase of +1, and the changes in the y is a +2. If I were to graphically represent that one, I could sort of sketch it to the side here and see that it would, in fact, look like a constant increase. So this one, therefore, from that evidence, is linear. Next up, there's a set of ordered pairs there. We need to look at the constant changes between every sequential x value and see if they change by the same amount. So this one goes, if I were to reorder these elements in this set, I'm going to put them in the order 1, negative 5, 2, negative 3, 3, negative 1, and 4, 1. You'll notice that the delta x is here. Again, we're looking at a 1, a delta y equal to 2. Therefore, again, this one is a linear set. Okay, so that one, yes, is linear. Determine the vertical and horizontal intercepts of the following graph. State your answer in coordinate form or ordered pairs. That means the same thing. Remember that coordinates are listed as x, y, and your vertical intercept occurs when you pass through the y-axis. Your horizontal intercept happens when you pass through the x-axis. Therefore, these two intercepts happen here and there. If I were to look really closely and this was really clear like it was on my original sheet, I would see that the vertical intercept happens at the coordinate 0, 1, x value 0, y value 1. And the horizontal intercept happens at negative 4, 0. X value first, y value second, just like in the alphabet. If algebraically I'm given an equation and I want to figure out what the intercepts are, all I need to do is I need to substitute in the zeros, right? The zeros in place for the x or y values, depending if I want the vertical or the horizontal intercept. So let's try to do that, shall we? So, to find the x-intercept of this equation, 2x less 4y is 20. I'm going to let y equal 0. I'm going to plug that into the equation. So it's going to be 2x less 4 by 0 is 20. That then is 2x is 20. Divide both the left and the right by 2. We get that x is equal to 10. Therefore, the coordinate where this intercept happens is x value 10, y value 0. Let's take a look at the y-intercept now of this same equation. We need to let x equal 0. So this will be 2 by 0 less 4y is 20. Then that's 4y, negative 4y is 20. Divide both the left and the right by negative 4, and you'll get that y is negative 5. That means that this intercept happens at y is negative 5, which is the coordinate x value 0, y value negative 5. The second equation, when the y is isolated, let's find the x-intercept. The x-intercept, let's let y equal 0. So if we're going to let y equal 0, that would mean that we have 0 equals negative 1/2 x plus 6. We need to isolate our variable. We'll subtract 6 from both the left and the right. We get negative 6 is negative 1/2 x from the 0 principle there. Divide both the left and the right by negative 1/2. And what happens is we get that the x value is equal to positive 12. So that means that the coordinate of the x-intercept is going to be 12, 0. The coordinate for the y-intercept, let x equal 0. That means that y equals negative 1/2 by 0 plus 6. You'll notice that it's really just the tail end of this equation, when it's isolated like this, that will be your intercept. Y is 6. That means the coordinate for this intercept is 0 for the y value and 6 for the x. So that's just sort of a little recap of things that are linear, things that are not linear, how to recognize that, and then a little bit of a conversation about intercepts. Intercepts are, if you imagine like two ships intercepting, that means it's where they come together. So we're looking at where they are on the y-axis for the vertical intercept and where they are on the x-axis for the horizontal intercept. Okay? Finn, put your phone away. Next up, we're going to take a peek at determining intercepts of a linear function. So in order to do that, here we've got a fuel consumption of a scooter with a full tank of gas at the beginning of a journey. Alex, put your Lego away. So remember that coordinates are x comma y, and we want to write the coordinates of the points where the graph intersects. So what I'm showing you here is sometimes we can get the intercepts just from the graph that's given. So I have one intercept here, and I have another intercept down here. Those are write the coordinates to the point where the graph intersects the y-axis. That's at x value 0, y value 8. If I want to know the coordinate where they pass through the x-axis, well, that's x value 200, y value 0. Capiche? You've just found the vertical and horizontal intercepts. Describe what the points represent in the context of the problem. So what this means in context, I have to write a little sentence here. The amount of gas in the scooter at the beginning of the journey. Which was 8 liters. In context, like I've got to use the units there. For the horizontal intercept, that means it's the point at which the journey is over. Because there's no more gas, right? Which would be 200 kilometers. If we're talking about the domain and range here, I'm going to write this in our abbreviated form, not our longer form. That would be that the possible values for x is that x is an element of 0 to 200. Square brackets, because I can include those values. There's actually a time when the distance is 0, and there's a time when the distance is 200. The range would be that y is an element of 0 to 8. Even though the graph starts at 8 high, the smallest value is 0 that it can be. So we write 0 first, 0, 8 in square brackets because we are including those edge values. So to describe what those intercepts are, the vertical intercept, or the y-intercept, as it's also known, is the point where the graph crosses, it's the point where the graph crosses or intersects, intersects the y-axis. And vice versa, the horizontal intercept, also known as the x-intercept, is the point where the graph crosses or intercepts. Again, sorry, I'm left-handed. The x-axis. Okay? So that's just a very brief determining the intercepts, talking about what they are in a given context, which I think will be helpful for you for your next assignment. Don't forget, I told the grade 9s that you can replay the speed on YouTube where I post this at 1.25 speed if you think I'm going too slow, or decimal 7.5 speed if you think I'm going too fast. There's a couple more examples there that you can practice for intercepts, and a couple page questions from the text if you happen to have that at home, if you would like a little bit more practice before you go to your assignment on that. Next up, let's talk interpreting slope. Again, not a great photocopy here for this one, but we'll be able to figure it out together. Yvonne recorded the distances she had traveled at certain times since she began her cycling trip along the Trans-Canada Trail in Manitoba from North Winnipeg to Graham Beach. She plotted the data on a grid. So you can see that we have distance in kilometer, time in hours, and we want to say what is the slope of the line through these points. What is its rate? How steep is it going up? So I noticed that for every increase of +1 kilometer, that the distance went up from 24 to 48. So that's an increase of 24. So the slope is given as the equation rise over run. And I think we've began briefly talking about that. We can now say that naughty word slope. So what that means is we went up 24, we went over 1, our units were kilometers and hours, so that means that the slope is 24 kilometers per hour. What does the slope represent? It represents the speed or rate at which the distance is increasing. Now we can either use our graph to determine the answer to question C here, using your slope to determine how far Yvonne traveled in 1 3/4 of an hour. That means we would just say if she started at distance times 0 here, distance 0, that means we would take the slope, which is 24 kilometers an hour, and we would multiply by 1.75 hours to get the value of how far we are in kilometers. We can kind of guess what it is here on the grid. Maybe it's somewhere between 36 and 48. But what I'm actually going to do for this is I'm going to punch this out on the calculator, which 1.75 times 24 is equal to 42. So she went 42 kilometers after 1 3/4 hours. Using your slope, determine what time it took Yvonne to travel 55 kilometers. So what we're going to do is we're just going to take the 55 kilometers and I'm going to divide by 24 kilometers an hour. And when I do that, I get approximately 2.3 hours. Okay. Again, a couple more practice questions there for you on that. That's the end of that lesson. In case you want to get to those from the textbook, I'll post a link to the textbook a little bit later, and I'll get your other videos posted here shortly. Thanks, guys. Bye-bye.